Okay, we're picking up in the middle of problem number 9. We did get cut off from our last video. So you can go back and watch video number 2 to see the beginning of this problem. All right, at this point we are in the middle of factoring. We've taken out the greatest common factor, -5, and now we are looking for two numbers that multiply to give us -12 and add to give us -4. Okay, and those numbers are going to be -6 and 2. So we still have our GCF out front. Okay, now we're going to take each of our binomials and we're going to set them equal to 0 so we can solve for t. So we're going to get t equals 6. We're also going to get t equals -2. Now, in this, it's talking about seconds. How many seconds? There's no such thing as negative time, so -2 does not make sense as an answer. So our answer is going to be t equals 6, so 6 seconds. That's how long the object is going to be in the air until it hits the ground. Number 10, 2 times Antonio's age plus 3 times Sarah's age equals 34. Sarah's age is also 5 times Antonio's age. How old is Sarah? We're going to take each of these sentences and turn it into an equation. Okay? We have two unknowns here. We don't know Antonio's age, and we also don't know Sarah's age. Okay, so our variables are going to be a and s. So looking at the first equation, or the first sentence, it says 2 times Antonio's age plus 3 times Sarah's age equals 34. So there's our first equation. All right, the next sentence says Sarah's age is 5 times Antonio's age. Okay, so we have two equations there. So this is a system. We can solve it either by graphing, substitution, or elimination. Because we have a variable right here, this s is by itself. Whenever you have one variable by itself, the easiest way to solve is using substitution. So I'm going to take what s equals, 5a, and I'm going to plug it in for the s in the other equation. Okay, so just like this. So I'm writing the first equation, but instead of writing the s, I'm going to write what s equals. Okay, and now I'm going to solve for a. So I'm going to multiply right here. 3 times 5a is going to give me 15a. Combine my like terms. And then divide by 17 to get a by itself. And a would be 2. That means that Antonio is 2 years old. Okay? Now our question said, though, how old is Sarah? So we're going to take Antonio's age and we're going to plug it back into one of those equations. It doesn't matter which one. I'm going to use the second equation because that one's the simplest. Okay, so I'm going to take 2 and plug it in for a. So that means that Sarah would be 10 years old. All right, number 11. The function f of x equals 2 times 2 to the x was replaced with f of x plus k, resulting in the function graphed below. All right, so, and then the question says, what is k? Basically what this is asking is that you have a function right here, and then this function has been taken and a number has been added to it. After that number has been added to it, it ends up looking like our graph right here. So, if you look at our original function, this number right here indicates where the y-intercept is. That means that it originally started right here. Okay? And now it has moved down as a result of plus k being added. It's moved down to -3. Okay? If you count how far it's moved down, that's 1, 2, 3, 4, 5. Since it's going down, that makes it negative. All right? So k would be -5. So that's one way to do it. Another option is to note that the change in the two graphs can always be found by looking at the asymptote. The asymptote is the line that the graph approaches but never crosses. So for example, if you look here, our graph is getting closer and closer and closer to hitting -5, but it's never actually going to touch -5. That's what we call an asymptote. Okay, and because the asymptote is at -5, okay, you could also notice that that would be the change as well. So either one of those methods works. Number 12. Suppose that the function f of x equals 2x plus 12 represents the cost to rent X movies a month from an internet movie club. Michaela currently has $10. How many more dollars does Michaela need to rent 7 movies next month? Okay, so here's our equation. And it says that this function represents the cost. That means that this is the cost right here. And then it says to rent X movies. So that is the number of movies. Okay, so Michaela wants to rent 7 movies. So I'm going to plug in 7 for X. And that'll tell us how much it's going to cost her to do that. Okay? Okay, so she's going to need $26 in order to rent that 7 movies. Okay, it says that she currently has 10. How many more dollars does she need? So if we take away the 10 she already has, she's going to need 16 more dollars in order to be able to rent the 7 movies that she wants to rent. Number 13. The larger leg of a right triangle is 3 centimeters longer than its smaller leg. All right, so we're actually going to stop right there. So I'm going to draw a right triangle. That means that it's 90 degrees. It says the larger leg. All right, so in a hypotenuse, this is the smaller leg. This is the large leg, or the long leg. And then this is the hypotenuse right here across from the right angle. Okay, it says that the larger leg is 3 centimeters longer than the smaller leg. Well, we don't know what the smaller leg is, so we're going to label that X. The larger leg, we know that it is 3 centimeters longer than the smaller leg. So that means the larger leg is going to be X plus 3. The hypotenuse is 6 centimeters longer than the smaller leg. So I'm going to take the small leg, and I'm going to add 6. How many centimeters long is the small leg? Okay, so we're going to set up an equation using our variables here on the sides of the triangles. Now, we know that the Pythagorean theorem is what we use when we have right triangles. It means that the small leg, if you take that and square it, add it to the big leg and square it, it equals the hypotenuse squared. So I'm going to plug in our formulas for each of those sides. So for A, I have X, and I'm going to square that, plus B is X plus 3, and I'm going to square that. Set that equal to our hypotenuse squared. Okay, so I'm just using the Pythagorean theorem here. Now I'm going to need to simplify. Okay, so I know that X raised to the second is just X squared. Okay, when I have this binomial raised to the second, that means I'm going to write that binomial twice. When I have 2 binomials right up next to each other being multiplied, I'm going to use either the box method or the FOIL method. Okay? So for X plus 3 times X plus 3, I'm just going to do that in the corner over here. Okay, so when I combine all of that together, I'm going to get X squared plus 6X plus 9. Okay, and don't forget, I do have my X squared over here. I need to bring that down. Okay, on this side, I'm going to do X plus 6 times X plus 6. Okay, so that's going to be X squared. I'm going to add my like terms there to get 12X plus 36. Again, I'm trying to solve a quadratic without using my calculator. So that means I need to get all my stuff, all my information over to the left side so I can set it equal to 0. Then I'll be able to factor to solve. So the first thing I'm going to do is combine any like terms that I see on either side. On the left side I have an x squared and I also have another x squared, so that's going to be 2x squared. Okay, so now I'm just going to continue moving everything to the left hand side. So first I'm going to move my x squared. Okay, next I'm going to move my 12x. All right, and finally I'm going to move my 36. Okay, so now I finally have everything on the left hand side. So now I can factor. All right, so I'm going to do the big X. I have negative 27 on the top, negative 6 on the bottom. I'm looking for two numbers that multiply to give me the top and add to give me the bottom. Okay, so that's going to be negative 9 and 3. So I'll take those and write them in binomials. Okay, then I'll need to take each binomial and set it equal to 0. And then solve for x. Now, the question, I finally have x, which is good. The question says, how many centimeters long is the smaller leg? Well, we can't have a negative distance. Okay, so negative 3 can't be it. So x is going to be 9. The small leg is whatever x is. So that means that the small leg is 9 and our units is centimeters. So that smaller leg is 9 centimeters long. All right, number 14. Katie and Jennifer are playing a game. Katie and Jennifer each start with 100 points. At the end of each turn, Katie's points are doubled. Okay, so that means at the end of each turn for Katie, they both start with 100. At the end of each turn for Katie, you multiply whatever point she has times 2. At the end of each turn for Jennifer, you don't multiply by anything. Instead, you add 200. Okay, every time. At the start of which turn will Katie first have more points than Jennifer? So if you look over here, I made a table, which is what you should do if you come across this problem. Okay, I have Katie and Jennifer. Again, Katie times 2 at the end of every turn. Jennifer plus 200. Okay, so first they start off with 100 points, right? That's how much they start off with. Initially, they have 100. Now, at the end of turn 1, okay, Katie, because we're multiplying by 2, now has 200. And then 400, then 800, so on and so forth. Okay, Jennifer, we add 200 every time. So on and so forth. Now the question says, at the start of which turn will Katie first have more points than Jennifer? And we're looking at the start of which turn. So if you look here, Jennifer has more points for each of these, okay, until we get here. At the end of turn 3, Katie has more points. So we're tempted to say that it's turn 3, right? But these are the scores at the end of turn 3. And they want to know at the start of which turn will Katie have more points. Okay, so the answer is turn number 4. That's at the start of turn number 4. That's when Katie will have more points than Jennifer. Which expression is equivalent to the cube root of ax squared times y to the third times z to the fourth? Okay, we know that when you take the cube root of something, it's the same thing as raising it to the 1/3. So what we're going to do is take everything that's underneath this radical sign, put it in parentheses, and we're going to raise it to the 1/3. Okay, now what I'm going to do is multiply my exponents, the exponents on the variables inside with the 1/3. With the coefficient, I have to take that coefficient and raise it to the 1/3. Okay, so this coefficient number 8, I'm going to raise it to that exponent that's on the outside. For all of these, I'm going to be multiplying whatever exponent it has by the exponent outside. Okay, now 8 raised to the 1/3, that's the cube root of 8, that is 2. Okay, now I'm going to be multiplying each of these. So 2 times 1/3 is 2/3. Okay, y, 3 times 1/3 is going to be 3 over 3, which is just 1. Okay, and I don't have to write the exponent if it's just a 1. And then z, 4 times 1/3 is going to be 4 over 3. Okay, and we're going to look to see which one has that answer, and it is B. Number 17, a school purchases boxes of candy bars. Each box contains 50 candy bars, and each box costs $30. How much does the school have to charge for each candy bar to make a profit of $10 per box? Okay, so they want to make $10 per box, all right? And they originally spent $30 on each box, and there's 50 candy bars in each one. Okay, so we have an equation here that I've written based on the information in the problem. So each box has 50 candy bars, okay? And each one is going to have an individual price of X. And then subtract the cost, the $30, and then have a profit of 10, okay? So $50 times whatever we charge, this is going to be the money that we charge, okay? That's how much we're going to make. We have to subtract the $30 that we paid for it, and then at the end we want to have $10 left. So now we just solve our equation from here. Okay, so 50x minus 30 equals 10. So I'm going to add 30 to both sides. And then divide by 50. Remember, this is still no calculator. We don't get to use the calculator till 40 over 50 is going to be 0.8. Okay, that means it's going to be 80 cents. We don't get to use the calculator till, I think, number 19. Okay, so in order to make a profit of $10 for each box, we would have to sell the candy bars at 80 cents. Okay, energy and mass are related by the formula E equals mc squared. So we're going to, it says which equation finds m given E and C. Okay, so here is our equation. All right, and we're looking to solve for m. We want to get m by itself. All right, in order to get m by itself, we have to get rid of the c squared that's over here with m. We're going to divide both sides by c squared so we can get rid of it. Okay, and so m is now by itself. You can write it like this, or you can flip it like this, okay? And that's how it matches D right here. Okay, this is the end of the third video. We will pick up with number 19 for the fourth video.